Hey there, sixth grade. In this lesson, we're going to talk about some properties of algebra that you'll need to know for this year and going into Algebra 1 next year. All these properties are describe the way numbers relate that you probably already knew, but maybe never really thought a lot about or gave a name to. Okay, so first of all, let's start with what the meaning of a property is. A property is just a statement or statements that are true for any number. Okay, so all these properties that we're going to describe down here below are going to be true for any number. And then also this phrase equivalent expressions, that just means expressions that have the same value. Okay, so there are 6 properties down here below that we're going to talk about in this lesson. The nice part about these is there's only 3 names you really have to know because each of the properties applies to one of 2 operations, either addition or multiplication. Okay, so we're going to start with the commutative property. The commutative property says that the order in which 2 numbers are added or multiplied does not change their sum or product. So first of all, we have a commutative property of addition. And all that's saying is that it doesn't matter what order you add numbers, you'll still get the same result. So for instance, 7 plus 9, we know 7 plus 9 is equal to 16. That's going to be equal to 9 plus 7. 9 plus 7 is also 16. So the order you add 2 numbers doesn't matter. The same is true if we used 2 variables. If I took the variable a plus the variable b, that would be the same as having the variable b plus the variable a. Okay, so that's what the commutative property of addition says. Okay, notice the same is not true with subtraction. For instance, if I took 15 minus 10, that would not be the same thing as 10 minus 15. Okay, because a smaller number minus a larger number would give you a negative number, which we'll end up talking about later this year. So the commutative property only works for addition. It also works for multiplication. The order in which 2 numbers are multiplied does not change their product. 4 times 6 is equal to 24. That's the same thing as 6 times 4. And then AB means A times B. That's going to be the same thing as BA. So that's what the commutative properties say. The associative properties, also for addition and multiplication, refer to the grouping of numbers. So the associative property of addition says the way in which 3 numbers are grouped when they are added does not change their sum. So for instance, if I took 3 plus the quantity 9 plus 4, and I grouped my 9 plus 4 together, that would give me the same sum as if I took the 3 plus 9 and grouped them together and then added 4. Okay, based off order of operations here, I would add 9 and 4 first to get 13, and then 13 plus 3 would be 16. Here I would do 3 plus 9 first, 12. 12 plus 4 is still 16. Okay, so the groupings don't matter. The same is true with variables. A plus the quantity B plus C is the same as the quantity A plus B plus C. Okay, the associative property of multiplication says the same thing. If I am multiplying 3 or more numbers together, okay, the way I group them does not matter. I could multiply 5 times 7 first and then multiply that by 8, or I can multiply 8 times 5 first and then multiply that times 7. The same is true with A, B, and C. I could multiply B, C, and then take that answer times A, or I can multiply A times B and take that answer times C. All right, so that's the associative property. Okay, the associative property has nothing to do with the order, but it does have to do with the grouping symbols. All right, the last properties we're going to talk about are the identity properties. There is an identity property of addition, which just says that adding 0 to a number does not change the value of that number. Okay, so for instance, 13 plus 0 is still 13. A plus 0 is still A. We also have an identity property of multiplication. Okay, that property says that when you multiply a number by 1, then the value of the number does not change. 7 times 1 is still 7. A times 1 is still equal to A. Okay, so again, all these properties apply to only the operations of addition and multiplication. Okay, subtraction and division behave differently and aren't really affected by, don't really have properties that say this. Okay, the order does matter when you're subtracting or when you're dividing, but not when you're adding or multiplying. So in these examples below, we're going to be given two different expressions for each example, and our job is to determine whether the two expressions we're given are equivalent. If so, we're going to tell why, what property is applied, and if not, we're going to explain why. So for number 1, I have the quantity 35 plus 17 plus 43, and then I have 35 plus the quantity 17 plus 43. All right, so notice that the order of the numbers is the same. I have 35, then 17, then 43. 35, then 17, then 43, but the groupings are different. Here I have 35 and 17, and here I have 17 and 43 grouped together. This is all addition, so this is an example of the associative property of addition, and based on the associative property, we know that this expression is going to be equal to this expression. Okay, so these are equivalent, and they're equivalent because of the associative property of addition. We will abbreviate associative ASSOC. You can abbreviate property PROP. And then addition will abbreviate ADD. So associative property of addition is the reason these are equivalent. Okay, number 2, we have 72 minus 63 minus 8. And then the quantity 72 minus 63 minus 8. Okay, this looks like an example of the associative property. It looks like number 1, except that we're using subtraction and not addition. And remember, subtraction does not have an associative property with it, so these would not be equivalent. Okay, we could go through and actually do order of operations on these. If you do 63 minus 8, that's going to give you 55, and then 72 minus 55 is going to give you 17. Here, 72 minus 63 is what we would do first. 72 minus 63 is 9, and 9 minus 8 is 1. Okay, so those are not equivalent. Okay, number 3, we have 80 divided by the quantity 10 divided by 2, and the quantity 80 divided by 10 divided by 2. Well, this is the same as number 2. Okay, we're using what looks like it might be the associative property, but our operation is division. There is no associative property for division. Okay, on this left side here, by order of operations, I would do what's inside my grouping symbols first. 10 divided by 2 is 5, so this becomes 80 divided by 5. 80 divided by 5 is going to give you 16. And then over here, 80 divided by 10 is going to give you 8, and 8 divided by 2 gives us 4. So these are not equivalent expressions. Okay, for number 4, we have the expression 0 plus 24 and 0. Okay, at first glance, it looks like this might be an identity property, okay, because again, we're using zeros, we're adding, but notice it says 0 plus 124 is equal to 0. That is not true. If you add 0 and 124, you get the original number that wasn't 0. Okay, you don't get 0 when that happens. Okay, so these two are not equivalent. 0 plus 124 is actually 124, not 0. Number 5, though, 59 times 1 and 59 are equivalent because that's the identity property of multiplication. If you take a number times 1, you get that number again. So these are equivalent, again, based on the identity property of multiplication. We'll abbreviate multiplication MULT. And then the last one, number 6, we have 7, the quantity 7 times 25 times 8, and 7 times the quantity 25 times 8. Again, notice the order is the same, 7, 25, and 8, 7, 25, and 8, but the groupings are different, and that's okay because we're using multiplication. So these are two equivalent expressions And that's another example of the associative property. This time it's the associative property of multiplication, though. All right, so if you have any questions over this video, be sure you ask those the next time I see you in class. And until that time, have a nice day. You're all wonderful people.